Hello and thanks for joining us on another one of our no fluff tech tip videos. This is Richard Jobson with TerraQuant. Today we are going to present one of our Can You Hear Me Now series of VoIP service assurance videos, finding common threads in service level anomalies using big data analytics. This week, voice quality anomalies. TerraQuant no fluff tech tips make the best use of your time, so we come straight to the point. Here you can see a dip in the MOS or voice quality throughout the time period in the purple graph in the middle there. We're going to analyze this anomaly in the service using a development we've built on top of the Elasticsearch Big Data Analytics platform. Here we are analyzing a collection of enriched call detail information pulled from Oracle's Communications Operations Monitor, a SIP monitor, stretching from early in February through to March, and we're seeing here that we have about 8 million call attempts, 4.5 million minutes of use. We've got the MOS, average MOS here and average call duration, and we're plotting the call attempts over time. We're also plotting the call duration. You can see here on the axis on the right hand side the call duration in the red line. We can see down here this particular IP address is responsible for most of the traffic, the darker shade of red. And down here we can see for the same time duration the voice quality. See here it's on average 4.0, which is pretty excellent, until towards the end of the time period it suddenly goes through the floor. Suddenly falls down to 1.5. Very bad. So the question is, how do we isolate in the network what is the common thread associated with the poor MOS? Here we can filter on, just by clicking on the blue area, we filter on calls with duration. We'll turn off the IP filter here at the same time. So the question is, how do we isolate this in the network? i.e., what is the common thread associated with the poor MOS? And how can we separate this from good calls? Let's focus on calls with duration, i.e. they've had a SIP response code of 200 OK, and filter out all the failed response codes such as 503.487, which have not had any voice or call duration. So we just click on this purple area here representing the 200 OKs, and it offers us a filter. Now let's not filter on the IP address, just filter on the 200 OKs. Let's turn off that IP address. And here we have different shades of red indicating high traffic intensity or volume. We still see the same volume of calls with the graph of MOS primarily relating to the calls with duration. This time with a single click, let's also filter on the specific IP address 10.100.2.30. And we see this IP address is responsible for at least some of the bad MOS. So let's turn off the IP filter and then check on these bars on the bar graph to see if other IP addresses are also responsible for the bad MOS. We can see for these next two IP addresses MOS remains good, high, up around 4. We see that this 1021.80.4 also is associated with bad MOS. And this last one, the voice quality is good. We note that these two IP addresses are associated with our international carrier, and that we are sending them all of our international traffic because they offer the significantly lowest rates. We therefore change our routing tables to send them only 33% of our international traffic. Over the next week, we will monitor very closely the traffic to those international routes, and meanwhile talk to the carrier about improving their quality. In our next video of our Can You Hear Me Now series, we will demonstrate how to detect telephony fraud using big data analytics. If you have any feedback or comments on these tech tips, we would be delighted to hear from you. Please message me on LinkedIn. Thanks for listening. See you next time. Bye bye.